and welcome to another MerMaid Lab software tutorial. This series of tutorials is based on the MerMaid software and the report section. Today we're going to discuss the evaluation reports. After you've opened up an evaluation report from 4/9/2013 through 4/23, which is about 2 weeks worth of data. Now, dimensions on this was a cylinder or a round well, 120 inches, which makes it a 10-foot diameter well. And here's your stop information and where your first start level was. So based on the level information, we calculate the volumes for the well. In the electrical section, Kurt used our step-down transformer to monitor the voltage for each phase of the station using a Y setup. And it also calculated what the phase-to-phase voltages were. We're looking at about a 480 volt system here, and we're looking at the unbalance of each particular phase, which this indicates that it's very balanced. When you get above 8% is when you start getting concerned how the station is running. Also, your run hours are very close and your starts are very close on this station. The efficiency, we calculate the voltage used versus the current, and we calculate the kilowatts used on each pump. Now, the more important part of this, I feel, is the calculation of the pump capacity. This is part of our flow algorithm, and we tune this pump capacity. This is the pump capacity for the duration of this report, 430 versus 449 gallons per minute. As you notice that the efficiency, though, is US gallons per watt hour, and it looks like pump 2 is just slightly a bit more efficient than pump 1. And you can also see that in the average cycle time for a pump down cycle, 3 minutes 38 seconds versus 3 minutes and 49 seconds. However, these pumps are very close. And this is a new station. I think it was commissioned about 3 or 4 months before Kurt was able to do the demo on it. With the annual cost analysis, we produce the annual cost projection of what it's going to take to run this station. We do that by, in our taskbars, putting in the utilities electrical costs and a power factor. Okay, so on this station we're looking at $895.82 if the power factor and cost information is correct. Now, pump 1, if you ran it by itself, if it was a single pump, it would run $919.92, where pump 2 is $871.37. Now, what we do to create the number, the annual cost of no electrical modifications were occurring, which means we're subtracting the most efficient pump from the actual annual cost. And this is basically what the utility's wasting. Because if you ran pump 2 by itself, you would save $24, which again, I say, this is a very good station. $24 is not enough money to even, fill a tank on a truck and run out to the station. It doesn't make any sense why you do want to bother with that. This is a very good station and very good results on the cost analysis, on the pump capacity analysis, the efficiency, the cycle time. Everything on this station is really pristine for a lift station. And it's showing that it's a very good performing lift station. Now, on the other hand, we have a demo file that we provide all our reps, and I want to show you this one. It's called Jacobs Creek. It's a triplex station. Now, before I get started, there's a story about this station. One of the pumps had an impeller issue. It was damaged. Something got into the station and damaged the volute of the impeller. And the manufacturer no longer was manufacturing that exact impeller, but the salespeople sold them an equivalent, would do the job. It mounted onto the pump, everything worked fine, and then we did our report. Now, this report was after the station ran 2 years with this impeller. You can see it's still a round well, 96 inches, which is an 8-foot diameter well. It's a pretty deep well, and they had good volumes, pretty good sized pumping station. Actually, they have the pretty large pumps in here. You can see by the current. And now, The voltage was fixed on this one. They did not have a multimeter to give us what the exact voltage was, but they said it was a 480 volt station. So we averaged out the 480 volts leg per leg at 277.1 with the average of 480 volts. What's interesting in this station is the balance is very good. The current balance for each pump. If there was an impeller problem, you will have a current imbalance. It's not an electrical issue. It's more of a mechanical issue. But you do see that there's a lower current on pump 2 versus pump 1 and pump 3. 39.5 on pump 1, 33.7 pump 2, and 38.2. Well, the glaring issue here, you can see it already, the run hours. Pump 2 used less current, but it ran 242 hours in a month, where pump 1 ran 83 hours and pump 2 ran 74 hours. You already know the pump 3 is more efficient, and the starts are about the same. So I instantly go down to the pump capacity. Here's one of the issues. That impeller is not able to pull as much water out of that station as the other two pumps. Pump 1's doing 1355, pump 3 is running 1460, and pump 2 is only 830. Well, guess what? Because it's the lowest efficient pump, it's pumping the largest volume. And you can see the US gallons per watt hour is 1%, a big difference between pump 1 and pump 2. Also, on the average cycle time, pump 1 is 2 minutes and 30 seconds, pump 3 is 2 minutes and 3 seconds, and pump 2 is 7 minutes and 13 seconds as the monthly average drawdown cycle time. That's incredible. So I don't know if this impeller was equivalent or not. I don't think so. I do know that pump 3 is the most efficient pump in this station. And this is further shown down here. The annual cost to run the station calculates out to $12,531. If you ran pump 1 by itself, you'd save $2,000 just running pump 1 by itself. Of course, pump 2 is going to cost you more. Pump 3 is $9,000. Well, that's $3,000 savings. What we do is, like I said before, we subtract the most efficient pump from the actual cost analysis for the year, and this is what they're throwing away a year. $3,000 on this station. Now that would pay for a new impeller, I'm pretty sure. But that's why I wanted to show you this particular report. There's not an electrical issue in this station. This station is a mechanical issue with the impeller. If you have a customer that's changed out impellers and they're not the original for the pumps, this report can give them a good understanding of where they stand on the efficiency of that station and their cost analysis of the station. Well, thank you again for attending my tutorial on the MerMaid Lab software, and I look forward to providing another one soon. Thank you.